In this video, we'll generate a dataset of decaying cosine using Euler's formula IMEXP, IMREAL, complex in Google Sheets or Excel. We begin with the values of V and W. So value of V is data validation, list of items from 0 to 0.4. So we can start with 0. Likewise, the value of W. This will be data validation, list of items from 0.6 to 1.4. So we can start with 0.6. Now the dataset of the decaying cosine, which is array formula, minus Vx, so minus V times x. That's exponent. So exponent minus Vx. That's the first part. The second part, cosine Wx, so times cosine W times x. And we'll chart this. Insert chart. And we use scatter chart. Row 1 is header. Show the trend line. And the type, polynomial. The degree 8. For the label, use the equation. Here's our trend line and polynomial of cosine, the decaying cosine. We continue using the IMPX of the Euler's formula. That is e raised to the power minus Vx plus Wxi, which is a complex number. So this will be equal to array formula. Begin with a complex number. This is a complex number, so complex Vx plus Wxi. So minus V times x, comma. The second part is Wxi. So W times x. That's the imaginary part. And enter. So we have, if we put this at 1 or 0.1, we have the imaginary and the real part. So we'll go back to 0. And we continue. That's e to the power of this number, the complex number. So IMEXP. So IMEXP. That's Euler's number. Now that we have the complex number, we want the real part. So this will be array formula. IMREAL of these numbers. So only the real part of these numbers. Now we can complete the trend line. Show the trend line. The type polynomial. The degree also 8. For the label, use the equation. So here's the trend line and the polynomials. Now we can continue with the values of W and V. Suppose we change the value of W to 0.8. Now the frequency of the blue one, which is the function, is increasing. And the Euler's cosine also catches up. The decaying function increase the frequency to 1. We can also change the Euler's function, the Euler's cosine, to 1. Change this to 1.2. Then this is 1.2. And 1.8, 1.4. This is also 1.4. So we change this to 0.1. We also change this to 0.1. Suppose we reduce the function here to 1.2. So we also catch up to 1.2. Change it to 1. Catches up to 1. Change this to 0.8. We also change this to 0.8. Change it to 0.6 W. And this is also 0.6. Change this to 0.2. And we change this also to 0.2. Now we change the frequency to 0.8. Change it to 0.8. Change it to 1. And it's also 1. Change it to 1.2. And change it to 1.2. Change it to 1.4. This also catches up. It becomes 1.4. Now they're the same. Suppose we go to 3. This also change this to 3. Now they're the same. Reduce this to 1.2. Reduce the frequency to 1.2. Or increase the wavelength. Increase the wavelength to 1. We also catch up. Increase to 1. 0.8. And this will be 0.8 also. 0.6. And this will be 0.6 also. Suppose we change this to 0.4. We catch up to 0.4. Now they're the same. Increase this to 0.8. We also increase this to 0.8. Increase this to 1. We increase this to 1. Increase this to 1.2. Also increase this to 1.2. 1.2. Increase to 1.4. And this is also 1.4. So this completes the use of IMEXP, IMREAL complex functions to generate the Euler's cosine for its decaying cosine function.